Good morning, Seven Raven. Before we start this class, may I just remind everyone of our e-classroom rules and make sure that you're all ready to learn, listen, and participate in today's meeting. To start this class, may I request Ms. Dumabak to please lead us to prayer. Amen. Thank you, Ms. Dumabak, for leading us a prayer. And before I give and introduce to you our topic for today, let us all refresh our minds and have a recap first in all of these terms. So in our previous discussion, I talked about real numbers and its classification, right? So to test, if you still remember, let's have this. Give an example for every specific group of numbers. Example, real numbers. It could be 1/2, 1, -2, etc. So what you're going to do is just give me one example for every number. Okay, number 1, for natural numbers. Yes, Mr. Dote? Very good. For number 2, positive and negative integers. Yes, Miss Yanong? Very good. For number 3, rational numbers. Yes, Mr. Garita? Very good. And for number 4, we have irrational numbers. Yes, Miss Bildua? Very good. And lastly, for whole numbers. Yes, Miss Talatala? Very good. So I can say that each of you really pays attention in our last meeting. So with that being said, let's have a small group activity. I have prepared here already your groups. Just refer to this table and check your group numbers. Okay, as you can see on your screen, we have here pictures of different objects. So what you're going to do is group them as you see fit and label each group. To answer, use the letters associated with each object. So every group has to choose one leader. And leader, please send your answers to my messenger account. And you can answer this in 5 minutes. Okay. Congratulations, everyone. You all got the correct answer. So let me ask you some questions. How were you able to come up with these labels? Yes, Miss Yunsai? Very good observation, Miss Yunsai. So she mentioned that what they did is to identify the object first and label it according to the group. Okay, for number 2, what made you conclude that an object belongs to a certain group? Yes, Mr. Dote? Very good. For number 3, did everyone found the answers by doing the same? Okay, very good, everyone. I can see that you are all ready for our topic for today. In our activity, we learn about sets and how to identify sets. So in this topic, we will be learning on how to describe and illustrate well-defined sets, subsets, universal set, and the null set. We will also learn how to write sets using raster or listing method and set builder form. And lastly, we will learn how to relate the concepts of sets in real-life examples. Okay, class, what is set? Set is a well-defined group of objects called elements that share a common characteristics. It was developed by a German mathematician, George Cantor. So if you encounter problems about sets like union of sets, intersection of sets, you will think of George Cantor. So set is usually represented by a capital letter and the elements are represented by a small letter. So there are 2 ways on how to represent a set. In roster or listing method or in set builder form. So in roster or listing method, can you please read Mr. Dote? Thank you so much. So from the word itself, listing. So what you're going to do is list all the elements and separate it by a comma and then close it with a braces. So as you can see in our example, we have here a set of 1 to 10 numbers. So it was enclosed by a braces and the elements or the numbers is separated by a comma. Next, set builder form. Please read Ms. Talatala. Thank you, Ms. Talatala. So all the elements of a set possesses a single common property which is not possessed by an element outside the set. So as you can see in our example, we have your set of natural numbers k. So k contains x such that x is a natural number. Okay, take note that the symbol, a colon, or a line placed between 2 x's stands for such that. For example, let A denote the set of even numbers between 6 and 14. It can be written in a set builder form as A contain an element x such that x is an even number, where x here is greater than 6 and less than 14. Now let's move on to the types of set. We have here well-defined sets, null set, subset, and universal set. What is well-defined set? Can you please read, Ms. Vildua? Okay, thank you so much, Ms. Vildua. Well-defined set is a set where the elements is clearly stated. So for example, the collection of positive numbers less than 10. So it can be written as A equals to the set of 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because it is said here that the collection only include positive numbers less than 10. So that is called well-defined set. Okay, for the null set, please read Ms. Braza. Thank you so much, Ms. Braza. So null set, from the word itself, null, it means empty, void, or wala o nod. It was denoted by the symbol this or this. So for example, let R is equals to X such that X, where X is greater than 1 and less than 2. X is a natural number. So can anyone give me a natural number between 1 and 2? Yes, Miss Dote? Very good. There is no natural number between 1 and 2. So that means that our set R is an empty or null set. Okay, for subset, please read, Mr. Garita. Thank you so much. So a set R is said to be a subset of K if every element of R is also an element of K. This means all the elements of R contained in K. So this means that ang element ni R para sa element ni K. Okay, this symbol here stands for is a subset of or is contained in. Every set is a subset of itself. We have here A is a subset of A and B is a subset of B. An empty set is a subset of every set. Okay, for example, let's set A equals to 2, 4, and 6. And set B equals to 6, 4, 8, and 2. So here A is a subset of B because all the elements of A can be found in the element of B. Okay, is there any question? Yes, Mr. Imbalia? Okay, Mr. Imbalia. Mr. Imbalia asked if it is possible that B will be a subset of A, and the answer is no. Since all the elements of set B are not contained in set A. Okay, for universal set, please read Mr. Intia. Thank you so much, Mr. Intia. So a universal set is a set which contains all the elements of other given set. The symbol for denoting universal set is a U or this symbol which read as she. The set, for example, the set of real number would be the universal set of all other set of numbers. So it depends on your definition of that given set. It can be a set of whole numbers, positive numbers, or positive integers, negative integers, and so on. Okay, for example, we have here set A is equals to 1, 2, 3, set B equals to 2, 3, 4, set C is equals to 3, 5, 7, and the universal set is 1, 2, 3, 4, 5, 7. So that's it. Is there any question? Okay, if there's none, let's answer this together. Please read the instruction, Miss Celestius. Okay, so what we have here is a listing method or listing form, and we're going to express this in a set builder form. So I will give you 3 minutes to answer this, and after 3 minutes, take a picture of your answer and send your answers on the chat box. Now let's check if your answer is correct. What we need to do first is to identify the elements. So for number 1, we have here, let set B is equals to 4, 5, 6, 7. So as you can see, these are all natural numbers, but it has a condition, and that is X should be greater than 3 but less than 8. So if we write this in set builder form, this will be our answer. Set B contain an element X such that X is a natural number, where X is greater than 3 but less than 8. For number 2, who can answer? Very good, Miss Yanong. So Miss Yanong answer is the set J containing an element X such that X is even number, where X is greater than 1 and less than 11. So as you can see, we have here 2, 4, 6, 8, and 10. So it is really an even number. Very good, Miss Yanong. So next, please read Miss Intia. Thank you, Miss Intia. So this time, what we have here is a set that is in set builder form. So what we're going to do is express this in a listing method. So I will give you again 3 minutes to answer this. And after 3 minutes, take a picture of your answer and send it on the checkbox. Now let's answer this. This time, what we need to do is to point out the condition, and that is X should be greater than or equal to 2 and less than or equal to 11. So when we write this in a listing method, we will get set Q is equal to 2, 3, 5, 7, and 11. And these are all prime numbers between 2 and 11. Who can answer? Very good, Miss Yanong. So Miss Yanong answer is set K is equals to 3, 4, 5, 6, 7, 8, and 9. So these are all set of natural numbers. Do you have any questions? None? Okay, I guess you are all ready for our quiz. This is just a short quiz. And I already uploaded in our assignment portal, so please do check it. I will give you 5 minutes to answer this, and take a picture of your answer and send it to the portal I provided. Write your answer in a clean sheet of paper and take a picture and send it in the portal I provided. All right, so I have received all of your papers already. So I will be checking this later and give your scores later. So if you have any questions, just send me a message and I will try my best to be as responsive as I can. So before we end our meeting, I want you all to send or comment in our meeting in 1 or 2 sentences in all terms and ideas that you have learned in this meeting. Before I forgot, let me give you your assignment. I already upload this in our assignment portal, so please do check it and you can pass it in a document form. And if you can't, just write your answer in a clean sheet of paper and take a picture of it and send it there. And always remember, student, life is a math equations. In order to gain the most, you have to know how to convert negatives into positive. So that's it. Thank you so much, student, for participating and listening. Now, let's end this class with a prayer. Mr. Dote, can you please lead us to prayer? Amen. Thank you so much, Mr. Dote. And thank you so much, everyone, for being here with me today. I hope to see you on our next meeting. Thank you so much. Have a nice day. Goodbye.